trigonometric identities. Okay, so I'm going to put a bunch of stuff here. Once you get your cheat sheets out, you can put this on your cheat sheets. Most of the stuff at the beginning you already know. And we'll add some things that you don't know. So again, this is really about a tool to help you manipulate equations, but these are tools that you've never had before. So just like you know how to do distribution, that was a tool to deal with parentheses. You're going to be given identities today to deal with trigonometry. Just like you've been told how to transform inches into feet, and then into miles, also seconds into minutes and hours and days. This is what we're going to be taught today to change and manipulate equations in trigonometry. So manipulating what you're looking at, not necessarily finding an answer. Now, eventually we'll use this to help us find an answer, but you're learning how to change the way your trigonometry equations look in order to solve them. Okay, so today is just about manipulation. All right, so let's just talk about the first set that you know, reciprocal identities. Okay, these are the ones that are very simple. So the sign is the same as what? Sine of x is the same as what? That's a fraction, 1 over the... Let me help you out, the first one. Right? 1 over the cosecant. Right? Cosine is the same as 1 over the secant, thank you. And the tangent is the same as 1 over the cotangent. Okay. So those are reciprocal identities. And you're going to use this a lot. So I'm gonna give you an expression, and I'm going to say, okay, make the expression with only sine and cosine. You also know that tangent is sine over cosine. So you're going to be given an expression, and you're going to have to manipulate it so you only have certain other trigonometry names in it, okay? That's how you're going to start today. The next thing is, all right, so that's the first part. Next one is Pythagorean identities. We touched on this last chapter, but just in case you forgot. Sine squared of x plus the cosine squared of x equals 1. Remember, this is just y and x on a unit circle where the radius is 1. You have a right triangle, the legs, x squared plus y squared equals 1 squared, which is something you're going to use here in the next chapter as well. So this is a Pythagorean identity, a squared plus b squared equals c squared, where c was 1. Then you had tangent squared of x plus 1, that equals the secant squared of x. And these are just Pythagorean identities. You just have to memorize this stuff. You're going to have it on your cheat sheet for your quizzes. Make sure you have it out for your homework and stuff. But you're going to get to the point where you're going to have this memorized. You're going to use it so much. All right? And these things you should just know. Notice that most of you really remembered this without any problems, and you didn't really need it on your cheat sheet. And that'll be the same for this. By the end of the year, you won't need this stuff. So 1 plus the cotangent squared of x equals the cosecant squared of x. All right. So those are your Pythagorean identities. Make sure those are on your papers. Again, you're going to use this with manipulation. Anytime you see the secant squared of x, you should be thinking, well, maybe I can rewrite it as the tangent squared of x plus 1. Okay? Anytime you see something with sine squared in it, you should be thinking, well, sine squared is the same as 1 minus the cosine squared. Right? You put the cosine squared. You can manipulate these as well. These aren't just set in stone. I could put cosecant squared of x minus 1, that equals cotangent squared of x. So I can change the way these look as well. These are just the basics. All right, then the last, well, there's 2 more, but let's just say it this way. These are called even even odd identities. And I'll kind of help you understand this. So if I said, before I finish that out, if I said, what's the sine of 30 degrees? Pi over 3. What's the sine of, pi over 6? 30 degrees. What's the sine of 30 degrees? What do you get when you do that on a unit circle? Sine of 30 degrees. 1/2, right? What's the sine of negative 30 degrees? Just think through it. Just down 30 degrees from the x-axis. What? Negative 1/2. Alright, so let me say this. What is, now you got those two. What's negative sine of 30 degrees? So you already told me sine of 30 degrees. What's negative sine of 30 degrees? Negative 1/2. So what you just told me was this right here. The sine of a negative degree, or negative pi over 3, however it's written, is the same thing as the negative sine of that degree, or pi. Okay? So these are just some things that you hadn't thought of, but when you see the negative in your problem, or in your expression, you know you can rewrite it with the negative in a different position, but that's not the same for all of these. It is the same for sine, cosecant, well, cosecant of negative x is going to be the same as negative cosecant of x, just because those are reciprocals, they work that way. Tangent of negative x is the same thing as negative tangent of x, and let's talk about that to make sure we get that. Remember, tangent is your y over your x. So let's just take pi over 4 because that's the easy one. At let's say tangent of negative 45 degrees. We're down here in the fourth quadrant. What's negative about that? The tangent of negative 45 degrees. That's going to be negative 1, right? Yes, you can square 2 over 2 over square root 2 over 2, but the y was negative, so it's a negative 1. Alright? What's the tangent, just the tangent, not the negative, what's the tangent of pi over 4? Isn't that positive 1? So you're up here, tangent of pi over 4, the square root of 2 over 2 over the square root of 2 over 2, right? That's positive 1, but I got a negative in front of it. So aren't those two the same? Alright, so I'm just giving you some examples to show you that it does work, that's all. So you can memorize this stuff, and you should probably just recognize this here in a second when I show you the next part. So the cotangent is the same way. Cotangent of negative x is the same thing as negative cotangent of x. Notice that we can just pull the negatives out in front if we want to. So this is manipulation. Where can we put the negative? Because that's important. If you think of your inverses and graphs and stuff, cosine and secant are different. And it's the same thing here. So if I give you the cosine of negative x, I'm going to have you kind of walk through what this is. So let's talk about the cosine of negative pi over 6. So what is the x value at negative pi over 6? So negative 30 degrees. What's the cosine there? What's the x value at negative 30 degrees? Positive square root of 3 over 2, right? Isn't that the same as the cosine of pi over 6? Positive, right? So the cosine of negative x is the same thing as the cosine of positive x. There's no need to have the negative in there. But you can put a negative in there if you need to. That's useful in some problems. Alright, so then you have the secant of x, secant of negative x is equal to the secant of x. So tangent and sine always go together. Cosine is usually set apart. Those are necessary. And one last thing. These are co-function identities. And we haven't even got into the problems yet, but this is what you have to use to do what we're doing today. So you're going to use all of this today. Co-function identities. We're going to think through these. Here's the first one. The sine, parentheses, pi over 2 minus u. We write that down first. Pi over 2 minus u equals the cosine of u. So let's think through this for a second. Let's say u is 30 degrees. And pi over 2 is 90 degrees. What is 90 minus 30? 60. So tell me what the sine value is at 60 degrees. The square root of 3 over 2. And notice you gotta know this your unit circle really well to understand this stuff. So the sine of 60 degrees is the square root of 3 over 2. You said we said u was 30 degrees. 90 minus 30 was 60. Sine of 60 is square root of 3 over 2. So if u is 30 degrees, what's the cosine of 30 degrees? Cosine of 30 degrees. Do I need to draw it? Square root of 3 over 2. Remember, it's the long leg. 30 degrees, the x is the long leg. Alright, that's why this works. So whatever degree you have, if you take 90 minus that, if you're taking the sine of that, it's going to be the same as the cosine. Right now, none of this means anything to you until you start using it, but that's something you can use. Alright, and it's the same for the rest of these. So cosine of pi over 2 minus u equals the sine of u. Notice they go together. Sine and cosine go together here. Tangent and cotangent go together. Secant and cosecant go together. Notice I didn't say sine and cosecant go together. That doesn't work. This is where it's different. So we need to be aware of that. Sine and cosine go together. Tangent and cotangent go together. And secant and cosecant go together. Okay? So this is the one that's a little bit different. You're not going to say sine and cosecant. And you can write the rest of this if you want. Tangent and cotangent. All right, well, I'll just do it. Tangent pi over 2 minus u equals cotangent of u. Cotangent pi over 2 minus u is the tangent of u. Secant of pi over 2 minus u equals cosecant of u, and vice versa. Okay? Alright, now that you have that down, keep that out in front of you. We're going to do some examples here. This is let's do number 3. The cosine of t times the tangent of t. I want this all to be made to look with just cosine and sine. So you're going to change what isn't a sine and cosine into sine and cosine. So how would I do that? Do I need to change cosine? No, I don't need to change that. What do I need to change? Tangent. Well, what do you know about tangent in terms of sine and cosine? Do you know anything about that? It's sine over cosine. So here we have, again, cosine of t times the sine of t over the cosine of t. Now it's written in terms of just cosine and sine. These are just practices to help you manipulate. They could have chosen anything, and we have 9 problems in here to help us manipulate. We can give you any problem and say do this. This is just what they came up with. All right, at this point, you simplify. Can I simplify this at all?
Yes.
What can I do?
Cross out the cosine.
Cross out the cosines. They cancel out, so I'm left with just the sine of t. There, you just manipulated this little expression to be just the sine of t. Okay, it's okay that it didn't end up as the sine. I want you to make it into sine and cosine, and then simplify it from there. All right. For instance, let's do number 5. Let's do a bunch of these. So the sine of theta times the secant of theta. You already have the sine. What do you know about secant, Tyler? What do you know about secant of theta? In terms of sine or cosine. What is the secant? Use your identities over here.
Cosine inverse.
Yeah. The secant is the same thing as 1 over the cosine. All right? Now, can I simplify this at all? It doesn't have to stay sine and cosine after this point. Once you get it into just sine and cosine, if you put it all together, does it equal something else?
Yeah.
Equals a tangent, right? Because if we multiply this across, we get sine of theta over cosine of theta, which is just the tangent of theta. Okay? So there's 2 steps. Make it into sine and cosine, and then simplify it as much as you can after that. So the sine of theta times the secant of theta is equal to the tangent of theta. Your goal in these first set of problems is just to change things, manipulate it as much as possible until you're used to using the identities. That's the purpose, to get used to it. There's only 9 problems, and we've done 2 of them. All right. Okay. So I'll do. Let's see. A little harder one.
Yeah.
Okay. We'll leave these identities up here so you can look at them. Let's do, how about number 9, I guess. You want to see an even one? Since you don't have those answers. How about number 10? Cosine squared of theta times 1 plus tangent squared of theta. They're a little bit different. Got some squares going on. It already has a cosine. What do you know about 1 plus tangent squared of theta? Equal to the secant squared of x, secant squared theta. It's also 1 plus sine squared over cosine squared. You could do that, but that would be a little bit messier. And some of your problems you're gonna kind of make a mess and fumble your way through it. But there's more than one way to manipulate sometimes. Okay? But yes, 1 plus tangent squared comes from this identity here. That's secant squared of theta, so cosine squared of theta times the secant squared of theta. What do we know about secant? Tyler, what do we know about secant?
The inverse of cosine.
It's the inverse of
Cosine.
cosine. Okay, so we have cosine squared of theta times 1 over cosine squared of theta. Now that you have it all in terms of sine or cosine, or both, you simplify.
The answer is 1.
Yes, it is. It's just 1. The answer is 1. Okay? Got this a little bit? Alright. I'll let you do the rest of those. Now, let's do, another one that's a little bit harder. That doesn't start out like that. Let's do number 17. secant squared of x minus 1 over secant squared of x. Put it in terms of sine and cosine, and simplify. Notice there's no equal signs here, so you're not solving, you're just manipulating. As you're working on it, anybody want to tell me what they think we should do first? There's an obvious one there. How about secant squared of x minus 1? What does that equal? Secant squared of x minus 1 is going to be equal to what? Tangent squared of x. So if we subtract the 1 over here, we have that. So we have secant squared of x, tangent squared of x over the secant squared of x. Okay, we still don't have sine and cosine. What do you think? How about we just start, can we change them into sine and cosine at this point? Huh?
You could mess with tangents.
Okay, so let's say that's sine squared of x over the cosine squared of x all over, well, Tyler, secant squared of x is the same as what?
Cosine.
Yeah, 1 over cosine squared of x. Well, now we got a very complex fraction, and that's okay. You're all pre-calculus students. This shouldn't scare you. How do I get rid of fractions inside of fractions? Multiply by the inverse. Reciprocal. So I have sine squared of x over cosine squared of x times the reciprocal of the denominator, cosine squared of x over 1. Now what? Fraction inside of a fraction, you always take the top number, whether it's a fraction or not, and multiply it by the reciprocal of the bottom. So that's where we got to here. Now what can I do at this point? Yeah, the cosines cancel out, and the answer at that point is just sine squared of x. You can't do anything else. I mean, you can keep manipulating. That's the thing with manipulations. You can just keep going. But we're done at this point. Okay? Alright, now, you got kind of a clue how to do manipulating. Let's put an equal sign in here, and let's verify some things. Verifying identity. Okay, so basically, an identity means it's equal to something. Tangent of theta equals the cosine of theta. So notice that on our identities, they'll have equal signs. Just meaning that you know that something's equal to something else. Alright, it can be changed. That's really what an identity is. Identity means equal. So you can say, as long as it's a true statement, as long as you have an equal sign and it's true, it's really an identity. So they just come up with all these different things that are equal. You just have to prove them at this point, or show that they are true. So I need to manipulate the left side and try to make it look like the right side. And you can do both of them at the same time. You can manipulate the left and the right until you get down to a point where they're totally saying the exact same thing, like 3 equals 3. Okay? So let's change the left side and see if we can get it equal to the right side without changing the right side. And some of these you're going to have to work on both. Okay? And yeah, it gets a little messy, but you know, leave yourself lots of space in order to do this. Let's change this one. Sine of theta. That doesn't, changing sine of theta isn't really helping us at the moment because that doesn't go with cosine of theta, but can we change tangent theta? Yeah, so again, you have something in the top of your fraction and over a fraction in your denominator. Well, what does that tell you? Riley, how we do this? You just did it on the last problem. You take the top, sine of theta, over 1 times the reciprocal of the bottom, cosine of theta over sine of theta. And what happens?
Sine stays left.
Yeah. And what am I left with?
Cosine of theta.
Cosine of theta, which equals the cosine of theta. There you just proved that that identity is true. You've shown that it's true. You verified it. So again, there's nothing really different from the beginning of the assignment to this. You just now have an equal sign. You have to show that they are truly equal. Another one? Okay. How about an even one? Will that make you happy? I'll leave the hard one for you guys. I'll give you number 38. This is how it's written in the book. Sine of x plus cosine of x squared equals 1 plus 2 sine of x cosine of x. And yes, you are going to do the binomial. It's not any different than when you were in 8th grade and you were squaring a binomial. Just because you have sine and cosine doesn't mean anything. Just trust what to do. Don't worry about how it looks. So I need to take sine of x plus cosine of x, multiply it by itself. Do not tell me that this is sine of x, sine squared of x plus cosine squared of x. That's not what that is. At this level, you should know that. So let's distribute and figure out what we get. Right, so far? Sine squared of x plus sine of x cosine of x. Sine times cosine. I can't put them together anyway. That doesn't do anything, so they're just there. Plus cosine of x sine of x, which those two are the same, plus cosine squared of x. Now, do you notice an identity anywhere in that? Do you have a sine squared plus cosine squared? Can I put this over here? Community property of addition? I can change things around. So sine squared of x plus cosine squared of x is 1. How many of these do I have? Aren't these the same? Isn't a times b the same as b times a? Commutative property of multiplication. A times b is the same as b times a. Sine of x, cosine of x, same as cosine of x, sine of x. So aren't these alike? How many do I have? 1 plus 1 is 2 sine of x cosine of x. And you're right. When you begin manipulating, you're not sure if you're doing it the fastest way. But what you started with at the beginning of this was they focused on changing everything to sine and cosine, and then simplifying from there. What you're doing here is you're looking at the left side and you're saying, how can I change that into what the right side looks like? It's no longer about sine and cosine. That was just the baby steps. Now, the right side is kind of telling you, how do I make the left side into that? It's directing you in that way. So, and sometimes you will change the right side as well. And yes, sometimes you're going to have a lot of stuff because you weren't sure exactly which way to go. Some ways are easier than others. There's more than one way. Got it? Here's your assignment. Page 498. 3 through 12 all. 14, 16, 18, 28, 38, and 44. I've done some of them for you in your notes, so you don't have to do the ones that we've done in our notes. Okay,